Hello everyone, welcome to our lecture on supervised learning. We will be talking about the supervised learning algorithm, and this is a uh, lecture in our lecture series on applied machine learning. A few details about myself before we go ahead with the lecture. If you want to access my work profile, you can visit this link and see all the projects that I have done. I have received several awards and have several publications in top tier conferences and journals. And these are listed here. You can also check it on my webpage. Currently, I'm an AI scientist and manager at EY India, where I primarily work on optimal hedging using reinforcement learning and also on the market surveillance using generative AI. I've received several child grant awards from prestigious organizations, including from Microsoft and Google as well. I have also worked on industrial robots at Sony AI Lab Tokyo, and there are several other awards as well. We also have a large AI community in India. If you are interested to join this community, you can visit this link and join us on different social media platforms on which we are sharing relevant information on artificial intelligence. If you want to join our WhatsApp channel, you can scan this QR code. If you want to subscribe our YouTube channel, you can scan this QR code. And so we regularly share information on AI, like how people are using AI in developing innovative projects or something, right? And we are also sharing details about like how is it that you can start learning the AI skills. So you can subscribe to our WhatsApp channel where we are hyperactive, and things will follow. So a few successes about our community is that several of our students are doing great, including Saksham from MSIT secured All India rank of 11 in GATE 2024. Amulya from MIT Manipal secured research associate position at Tripartite Delhi, and many students published papers in top tier conferences and good demos, higher studies, and so on. Right. So there are so many things that our students are able to do, and that is becoming possible because of the communication, the networking we have in the community. So there are several mentors under supervision of which you can work on great projects. So these are the experts in the industry, like they have strong credentials. They are from the top universities all over the world, and they are working in top industry all over the world. Okay, so in today's talk on supervised learning, we will be first seeing some introduction about ML. I think in the previous lecture of this talk series, also we covered this, but we'll have a brief intro here about machine learning. We'll see like the type of learning algorithms and how is it that we can use a data set for ML algorithm, and then we'll see supervised learning algorithms and evaluation metrics. So I will be giving only a brief introduction. And for each of the individual algorithm, we'll be having a separate lecture. Okay. So for example, as we have seen in the last lecture as well, machine learning is a collection of methods or algorithms which are used to make computers understand patterns in the data without explicit programming. So these methods enable machines to improve with experience. So for example, let's say if we consider machine learning algorithm as a black box, then we are feeding data to this algorithm and then we are getting some kind of understanding. Okay, that kind of understanding that we want to get depends on the algorithm we are training. Okay, so we will be talking about that. So that means using machine learning, we are teaching computers to understand the data. So if we are having image and video data, we are making the computer to understand the perception problem in the computer vision tasks. Okay. Similarly, for text and speech data, we are training the computer to do natural language processing, and we are giving the human-like capabilities of understanding text and speech. Okay, so any data set that we have seen in the last lecture as well. So we actually do the data set splitting. So let's say if this is our original data set, this is the length of original data set, we split it into training and testing data set, and the training data set is usually split it into training and validation set, where on the training set we train the ML algorithm, and then to improve the ML algorithm, we need to do some fine tuning. We need to adjust the hyperparameters, and then we will evaluate it on the validation set, so that we can adjust the best parameters where the accuracy on the validation set is coming out to be good. And then the trained model is actually tested on the testing data, so where the final performance is reported. And here we claim that, okay, so this is the performance of our ML model. We'll see how these things are happening. So we need to do several important data set operations as well. So for example, let's say if I'm talking about data pre-processing, we may need to do the data cleaning, handling missing values, removing duplicates, data transformation, like so for example, data normalization, scaling, etc. We may also have to do data dimensionality reduction. So where, let's say, the data set, like one particular sample has a very big size, so we may have to reduce that as well. So this is about the classical ML algorithms, but in the recent days, we use deep learning where we don't have to do dimensionality reduction. Okay, but we have several algorithms in deep learning as well where dimensional reduction is done. Okay, so sometimes we also have to do feature selection. So these things we need to do, but don't worry if you are not understanding it. We will be covering these in detail in the future lectures. So each individual topic we will be covering in the coming lectures. Okay, so but I'm just giving you an overview how the complete pipeline is actually working. So what are the supervised and unsupervised learning methods? So where supervised learning methods, we have the data, we have the annotations, and we are making the computer to learn some pattern which actually says that, okay, this input data is associated with these particular labels. Okay, it is learning it, and then when the newer sample comes, it is leveraging its learning, and it says that, okay, do the prediction based on the learning. Okay, so for example, here it says that it's an apple. In unsupervised learning, we have the data, but we don't have the labels. Okay, so that means we are learning some patterns which are based on some features, right? So maybe some similarity matches, right? So for example, the input data which has the similar appearances are actually grouped into similar items, right? So for example, here the red circular shapes are in one category, circular shapes are like light red, yellowish in one category, and the yellow not so circular shape is in the third category, right? So this is unsupervised learning. There is another learning as well where we don't know, we don't even have the data, right? So for example, there is an agent which actually needs to learn to do decision making in the unknown environment. Then what it will do is it will actually take some action, it will get the reward or penalty, and then when the negative reward is given, okay, so it says that, okay, it's a bad action, I should avoid it next time. Okay, so it will update its learning, the policy is its learning, and it will iterate until the optimal steps of actions are learned. Okay, so for example, like going to the tap, filling the bucket, and then throwing the water on the fire. Okay, so it will randomly execute all the actions, will learn which is the best one. Okay, so this is how reinforcement learning works. Okay, so if we see these in brief, in supervised learning, we are learning from the data with labels. So for example, we have xi's and yi's. When the number of samples, let's say we have n, x is the data, y is the label. In unsupervised learning, we are learning from the data without any label. Okay, so that means we don't have yi here. In the reinforcement learning, we don't have even xi. Okay, so here we are learning from interactions with the environment. Okay, so this interaction is actually this, the current state of the environment, the action the agent takes, the reward it receives, and the next state of the environment. Here we do typically two tasks. One is the prediction from the current state and the action taken, what is the next state, or maybe from on the current state, what is the optimal action that we should take. Okay, so that means the optimal behavior that we can see. A few ML methods that we have. These are the very important ML algorithms, very commonly used as well. I think from past 2 decades, these are heavily used in the industry, and most of the companies are actually depending on these algorithms. Okay, so for example, in supervised algorithm where we have the data with labels, we have algorithms type regression and classification, where I will be talking about what these are. In unsupervised learning, we have clustering and dimensionality reduction based algorithms, and then the reinforcement learning, we have deep Q networks, which are value based methods, proximal policy optimization, which is kind of like it's an on policy method, like so direct policy learning we are doing. AlphaGo, which is a kind of a tree-based method. Okay, so let's just see about supervised learning. In supervised learning, it's a type of machine learning where the model is trained on labeled data, meaning that input comes with the corresponding output labels. Okay, so it's a like we already have the label data, and we also know the like what are the labels associated with the data. Okay, so the key idea here is that the algorithm learns to map the input data or the features to the correct labels by minimizing prediction errors. Okay, supervised learning algorithm, the process that we follow is like first to do the data collection. We gather a labeled data set with inputs and outputs, and we do the training. Like so, for example, we feed the labeled data into a learning algorithm to create the model. Like so, the commonly used algorithms are decision trees, SVMs, neural networks, and then we do the testing phase. Right, so we evaluate that the created model's performance on unseen data. Right, so that the test data. I think if you go back to a few slides back, so you will see that, okay, so we already created a split of the data set in the training and testing set, where the testing set that we created will be used to evaluate the model's performance. Okay, so this is a brief about supervised learning. Let's say if we see the commonly supervised algorithms that we have, one is the kind of classification based methods where we predict descriptive labels. So for example, whether the image that we have given belongs to a cat or a dog. The algorithms are logistic regression. Like this is a classification algorithm. Don't confuse it with the regression. This is a basically type of regression algorithm, but it is used for classification. Decision trees, support vector machines, and k-nearest neighbors are the classification methods. So for example, here, this is our classifier model. We have given some input image. It will say, okay, so to which of the known categories this input belongs. Okay, so here the learning algorithm will actually predict the probabilities. Okay, it says the 0.1 chances that it is from the banana category, 0.9 chances probability that this belongs to the apple category, and then I think this is berry. So it actually says that, okay, 0.5 probability that it belongs to berry. Okay, and then we choose the maximum of them, or maybe we can do the entropy, or maybe we can do the softmax, and then we'll find out which has the maximum one. So the output probability distribution will be 0, 1, 0. So that means it belongs to the second class, which is apple. Okay, another commonly supervised learning algorithm is the regression, where the goal is to predict continuous values. Example, we may want to predict the price of the house based on certain conditions. We may want to predict the temperature tomorrow. We may want to predict the temperature inside a room based on some conditions. Okay, so that means that we are predicting the continuous values. The common algorithms are linear regression, polynomial regression, ridge or lasso regression. We'll be talking about the regression in detail in the coming lectures. Okay, so so these are the commonly used algorithms. But what are the evaluation metrics that we have? Like for supervised learning model evaluation, we have accuracy is like one of the commonly used algorithms. The percentage of the correctly predicted samples or the labels. This is commonly used for classification. Then there is precision and recall. Precision says that how many of the predicted positive cases are actually positive. I will be talking about the evaluation metrics as well in the great detail in the coming lectures. But for now, I'm just giving an introduction. How is it that you will report the performance of a supervised learning model? Okay, so another is a recall, where how many of the actual positive cases are identified. Okay. F1 is the harmonic mean of the precision and recall. Then there are called as type 1 error, type 2 error, or maybe true positive rate and the false positive rate are also reported. And then if you talk about regression, one of the commonly used metric is the mean squared error, which is used in regression to measure the average squared difference between actual and predicted values. And one of the commonly used like matrix for multi-class classification is confusion matrix, which is a table to describe the performance of a classification model by comparing the predicted and the actual labels. Okay. Okay, so these are the evaluation metrics. I think like you should know about how a model is trained. So I think three things are very important here: how the data set is actually set up, how the model is created and how it is evaluated. Evaluation is a very important step, and sometimes in the supervised learning models, there are like you may see that there are two phenomena you may see. One is the overfitting and one is the underfitting. So overfitting is actually in this particular case, the model performs well on the training data but poorly on the unseen data. Testing set accuracy is very poor, but the training set accuracy is very good. Okay, so here to actually check this thing, there are so many things that can be done. So for example, you can use techniques like cross validation. You can do the pruning. That means you can adjust the size of your model. Like for example, for decision trees, pruning is one commonly used approach. For other classification algorithms where there is an objective function, we use regularization, which is L1 L2 regularization. We'll see what these are, how to do it, and all those things we'll see. Okay, another phenomenon is underfitting, where the model is too simple and fails to capture the underlying pattern. So here we have very poor training accuracy, forget about the testing accuracy, right? In that case as well, right? So this is a very common scenario where the model is too simple. Here the solution is to use a more complex algorithm, or maybe to add more parameters to them. Okay, so this is a very simple stuff. I think you may not see several instances where your model is underfitting, but if it is underfitting, just simply use a bigger model. Okay, and then there is overfitting. Overfitting is commonly occurring phenomenon in the machine learning, and to avoid it is actually a very interesting aspect, where you will leverage your engineering creativity, and will see like how is it that you can overcome underfitting by using these algorithms. Or there could be several other ways also by which you can avoid overfitting. So for example, data augmentation could also be one. If the data set is lesser in size, you may see that the model is overfitting. Okay, we'll see all of these things in great detail in the coming slides, in the coming lectures, I mean to say. Today, I think we were only talking about the supervised learning. So I hope I have given you a little overview about the supervised learning. So we'll in the next lecture we will be seeing about unsupervised learning, and then we will be continuing with the prompt engineering and the reinforcement learning, right? I think today's lecture was very simple. It was just an introduction. I think in the coming lectures we'll be talking about the details of the algorithms. Okay, so join our AI club, Think AI club, where we are sharing all the information related to AI. So this is a WhatsApp channel, and this is the YouTube channel QR code. And if you want to connect with me, you can connect with me on email ID, or you can go to my web page and see like what kind of projects we do. Okay. So thank you for joining, and also suggest like what kind of lectures you want. Maybe comment, and I will try to. Okay, I will try to see like what kind of lectures I can take in the future. If you want me to take some lectures which are specific to your needs, I think we'll do that. Okay. Okay. Thank you everyone for joining.